Hey guys, welcome back to my channel. I've got a little project here on the bench tonight. This is a real basic little vegetable steamer. This is a Secura brand vegetable steamer, and it's 1200 watt. And if you're interested in the model number, it's a DZG-A80A1. So it's a pretty basic unit. You put water in here. It's got a heating element inside here. There's a metal basket that sits on here. You put your vegetables in there, and then it's got a cover that sits on top. And there's also a metal piece that sits in the center here. It acts like a diffuser. But what we noticed last time we went to use it was we were cooking Brussels sprouts, and we put in the time we usually put in for Brussels sprouts, and they came out a little too al dente. So we just did broccoli in it tonight, and same problem, another fail. So the interesting thing about this failure to me is the fact that it's not cooking them at all, it's just not cooking them enough for the same amount of time. So I thought about it and I said, well, the science is pretty basic. It heats the water up, creates steam, and the steam cooks the food. So it's either heating or not, right? So what could be going on? Well, then I noticed that there is 3 power levels, apparently. Low, medium, high. I never really paid attention. We always used high. And then I decided to do a little experiment. I fired it up with some water in it with no cover on it and just watched when it started making steam. And then I played with the power level settings, and I made the following discovery. We'll just put a little bit of water in there to get it going a little bit quicker. Alright, so I've set it for chicken, which is high power, 14 minutes. So what this will do is this will wait until it starts to heat the water up to a temperature that will start making steam, and then it'll start counting the timer down. I'll pause the camera and you'll be right back in a minute. Okay, it's been a couple of minutes and it has started to make steam, and the timer is counting down. However, it's not making as much steam as it normally does on this setting. But this is what I noticed that caught my eye. If I switch the power level while it's on high, that's medium. Watch what happens. There's a click. And it pretty much all but stops. Now, watch what happens when I push it to low. Now it's on low. You hear another click. And we'll give it a second. And look. It's heated back up again. But it's only heating up about the same on low as it is on high. So what I've figured out is that when it's on high and low, it's steaming the same amount, and when you put it on medium, it pretty much stops steaming altogether. So I have a theory. My theory is that the way this unit gets 3 different levels of power is that there are 2 heating elements in this thing. And that what it does is on low, it uses a low element. And on medium, it uses a hotter element and shuts low off. And on high, it turns both elements on. That's the only logical thing I can come up with that would explain why it doesn't heat at all on medium and heats almost the same on low or high. So I've never had one of these particular units apart before. I see 3 pretty obvious screws here, and then there's 1 screw here near the plug. Alright, after fussing with this a little more, I got a screwdriver in here, in these openings right here, and I pushed down and was able to pop this plug free. Hey, so I want to point out, this video is for entertainment purposes only. If you're going to take one of these things apart, do so at your own risk. There is a risk of electrocution. So I am getting out a screw that you guys can't even see. And I'll show you where this was. Alright, so now I got that screw out. So now that whole cover should... No? Yep, there we go. Alright. So this is the plastic cover. There's the circuit board. Okay. Alright. With me so far? There's where that screw went. And then the back of this just clips in to this right here, these two plastic tabs. Alright. And what I just discovered about this thing is that I took this apart incorrectly. Remember I took a screw out over here? I took that screw out right there and I thought that had to do with keeping the plug in. The plug just snaps into the base. So I'm looking at it and I'm like, well, what does that screw do? Well, what that screw does is that keeps this bottom piece attached to the top. But I'm like, well, wait a minute, just one screw? Why is that? Yeah, just one screw, because the rest of it is all plastic snaps. It snaps together. It is that cheesy. So it's not exactly coming apart easy. Oh, there you go. Just force it. Did I break it? No, looks like I still got tabs there. Okay. So now you see the method to the madness here. So now this goes on like this. Right. Okay, so it's clear to me, as you can see, that there are two heating elements here. This end of each one of these heating elements is tied together, so they're common to each other. And then on this end of the heating elements, there's one connection here and one connection here. So what we have is we have two heating elements that can be individually switched on and off. And we know we have three power settings, low, medium, and high. So my theory sounds like it's going to be true, correct, as far as that the way this works is that it uses one element for low, another element for medium, and then puts both elements on at the same time for high. I'm still going with that theory until I'm proven wrong. So let's look at how the power comes in. The power comes in, the AC comes in here, goes over to a thermocouple. This is a device that if this surface gets too hot, like if the water boils out and it's dry and this gets too hot, this will open and cut power going to this leg here, which is what supplies these relays. The power comes also over to this side of the board, and then this is the neutral. So the blue wire is the neutral, comes over here, it goes through another thermal fusible device and comes over to one side of the elements and over to the board. So what they're doing is they're sending power to the board, 120 volts AC to the board here, to run the electronics. And then they're also sending the 120 volts over to this side of the board to be just switched through the contacts of these relays. The smaller relay is for the smaller heating element. One of them's lower wattage. And this larger relay is for the larger heating element. I already checked the electrical resistance, and one of these has lower resistance than the other. That's going to be the hotter element. And the hotter element, higher wattage element, is going to be switched by the larger relay. This relay is rated at 15 amps. This relay is only rated at 10 amps. So I'm going to take this one screw out right here. That's what's holding the PC board into this plastic tray, so that I can actually get a look at the back of this and make sure that there aren't any damaged circuit traces on the PC board near the relays, because it could be a burnt connection there that could be causing all the problems. And that's not the case. That looks actually okay. Oh, at this point I should probably make it clear, in case it isn't already, that even though they're using a blue wire on this side, this is not a neutral like on this side. So remember I said they're sending power to this side, 120 volts AC to power the board, power the electronics here, and then they're also sending the power over here, but they're only sending the hot AC over to here. So you can actually see there's a color change on the other side of this thermal device right here, from red to blue. So this is actually the hot AC coming in, and then it has the ability to, from there, comes in right here at this point, it goes over on this trace to one of the connections on the small relay, which is right behind here, and one of the connections on the large relay, which is right here. When this large relay closes, it makes a connection between this point and sends power back out on this black wire to this outer element, the larger of the two elements, which has a lower electrical resistance and is the higher wattage one. On this side, it goes to the relay here, and when this small relay closes, it sends the power out onto this red wire to this inner smaller element. So that's the low power element relay, and that's the high power element relay. So now what I'm going to do is I'm going to disconnect the elements so that I can run this on the bench and simulate it cooking without the elements actually getting so hot and causing a problem. It might look like a mess, but there's actually some semblance of order here. I've got this yellow wire going up to the connection that where the two elements are tied together. That would be the connection on the neutral side. It's even got an N cast into the metal, so I know that that's the neutral. So I'll keep 1 meter lead on that, and then I've disconnected the two wires going to the two elements. I've got one jumper on one of them and one jumper on the other. So now I can connect my meter either to the low side or the high side. I've already plugged it in. If you're nervous about me touching the back of this board is low voltage only because it's the logic board. It's that board there that we don't want to go touching anything, or any of these wires for that matter. So right now, we're looking at this upside down. Right now the unit is off. So if let's see. There we go, okay. So that's the chicken light. All right, just heard a relay close. So it is on high. This is the high light, this is medium, this is low. 14 minutes, so right now, we heard that click. The high element, so actually I think both of these should be on right now, but definitely the black wire was going to comes off of the larger relay. This should definitely be energized right now. And it is not. Okay, so there is most likely our problem. Let's see if there's anything on the low side. The low side is on, which makes sense if I'm right about the fact that both elements have to be turned on for it to be high. Let's toggle it to medium. Now, when I put it in medium, I hear a click, and this relay opened and shut off the low element. And we still have no power on the high element. And now let me click it again to low power. Give it a second. Here's another click. Low power. The low element has turned on again. And the high is still not working. And it's got like 2 volts, so it's almost like there's some leakage AC getting through. So my suspicion is that we've got a bad contact in the relay. Just for the heck of it, just to rule out the possibility of it being this black wire having a break in it, I'm going to go right to the relay, put it back on high. So it's on high right now, going right to the relay. Still have no power. I don't know if you can see the meter or not, but it's showing me like 2 volts. Sorry if you guys aren't seeing what's going on over here. So it's definitely this relay. I want to try something else just for the heck of it. I'm going to keep this hooked on. Got 2 volts there. And what I'm going to do is I'm going to watch that meter. And I'm going to tap on this relay case. Nothing. Okay. So either the relay contact is bad, or the relay coil is open, or the coil is not getting any voltage. So it could be a switching problem. It could actually be something with the circuit here. There's a driver transistor that drives that relay. It could be that that's not turning on or off like it should, or it could be that that transistor is bad. But the easiest way to rule all that out is to just switch my meter to DC voltage and look for DC voltage on the coil of that relay, which is going to be this connection and this connection. Alright, I've got my meter back on DC voltage. I've moved my one of my jumper wires to one side of the coil on the relay, and if I put my probe on the other side of the coil, I'm getting 12 volts DC. So the coil's getting power. It should be energizing and closing those contacts, and they're not. So there's something wrong with that relay. Interesting. I just tilted the board this way, like this, and wrapped on top of this, and boom, the relay turned on. Oh, it just turned off. Oh, because the countdown timer reached its end. Alright, so let's do this. Let's turn it off. Let's turn it on again. And there we go. And again, it's not working, see? 3 volts. Right now that should be 120 volts because the high temp element should be on. And the low temp is on. This element right here should be on. Watch this. Tilt it like this. 3 volts, right? Boom. Whoop. Oh, my lead just fell off, but it just went to 123 volts. Well, I decided, since the relay wasn't working anyways, that I was going to do a little autopsy on it, break it open. The relay in question, part number is a YX202-S-112DM. It's a pretty common relay. They literally are calling it a pressure cooker relay. Used thermos kettles, rice pots, soy milk makers, blah blah blah. But as far as why this one failed, I think we just found out. I broke open the plastic case, and what do I see here? Rust. Moisture got inside this unit and decided to collect in here and cause problems. So that is what's going on. Well, the relay's certainly cheap enough. Problem is, it's like, to get it fast, I'd have to order it on Amazon, and they're only sold as 5 packs for like 25 bucks. So I'll end up having 4 extra ones I don't want. And if I want to get them cheap, I gotta order them, have them shipped from China. I'm not gonna wait that long without a vegetable steamer, so I have
China. I love them.
at my disposal a bunch of random PC boards from stuff I've worked on over the years. This is from a Sundance hot tub. It's loaded with relays. These are heater relays, they're way too big. These are pump relays, but then there's these little auxiliary relays right here. I already took one out. And wouldn't you know it, these are all 12 volt coils, and these are 10 amp, which is the same current rating that I need. The problem, and what makes this silly little rice cooker relay annoying as heck, is the way that they pin this. So what they did was it's 3 pins all down this end and 1 pin up here. This is more logical. These 2 pins that are in line down here are the coil pins, and these 2 pins that are offset but at least are at the other end of the relay are the contact pins. It's a single contact relay. This is a single contact relay, but they did some weird stuff here where they've got one of the contacts pins is here and the other one is, well, it must be the center one, I guess. I don't know. I could look at the board and figure it out, but I really don't care. By the way, check out the rust. Alright, so what I'm going to do, I do not recommend doing at home. I don't recommend doing any of this. Proceed at your own risk. I am going to jury rig this with some wires to wire up electrically into this thing, and then just kind of have this thing, you know, shoddily hang around in here. I started by tacking on, actually wrapped these around, soldered these 2 small conductor wires to the coil connections. And with these thin wires, what I'll be able to do is insert the other ends of these wires into the holes on the board where the coil connections for the old relay would go, and bend them back like this, and that'll let me kind of have this relay live right kind of like this, floating above the board. And then I'm going to put some stiffer wires on here, some solid conductor wires, and what those will do is they'll be able to handle the higher amperage that flows through the contacts, but they will also kind of do double duty and help to kind of keep this coil from just flopping around in here loosely. Alright, there we go. So I've got these stiff wires. They're just leads I cut off of an old axial lead component, and then these small wires here for the flexible wires for the coil. So now I just got to get it into the board, and then the trick is I got to solder it quickly so that the heat doesn't travel up here and want to try and undo these connections on me. Alright, I finished up wiring in my relay here. So now let's try a test. And there we go. My new relay just closed. 123 volts coming through it. That's good. So this is the high setting, high power element is on, and the low power element is on. Now when I put it to medium, remember before, when I would put it to medium, it would just shut off altogether. So the low power element shuts off, and the high power should be still on. And it is. Alright. So now we're just going to carefully reassemble this thing. Alright, let's give this another shot. And that should be high. Oh yeah, that looks like that's a lot quicker and a lot more action. Yeah, it's definitely a more active boil. Alright, kick it down to medium. and it should stay on. It should just calm down. There we go, it's slowing down, but it's not shutting off like it was doing before. And then low. As you recall before, low and high were the same. And we'll kick it back to high. And now that other element's heating back up. Alright. Okay guys, I'd say this is a successful repair. And a lot of you are probably wondering why go through all of that trouble of wiring up that relay when you could have just bought the correct relay, or why not just replace the whole darn thing? Well, part of the reason I did this was just to see if I could do it. Heck, I think that's why we went to the moon. Another thing is, I looked this unit up. We bought this off of Amazon. You can still buy this unit off of Amazon, and this is a $100 steamer. So we actually bought a better. I don't think we paid that much for it at the time when we bought it, but I think when I looked at the reviews and everything, that's why we ended up buying this one. One of the things I liked about this one, as opposed to our previous steamer, this has all stainless steel baskets. It's got two baskets that can stack, and they're all stainless. Our previous steamer, this was actually some sort of a composite plastic material, and that was some sort of a black, like rubberized material down the bottom there, and the plastic piece, the basket was plastic, and I just didn't like the idea of that. You know, over time heating up, any chemicals in that plastic coming off, that kind of thing. So I just thought this would be a easier to clean and healthier choice. So, alright, I hope you guys enjoyed this video. If you did, please hit the like button. If you're not already a subscriber, please consider subscribing. You never know what I'm going to get into next. Take care.